Alrighty.
Okay, can I come back in? We're all set on this side. It was nice to meet all of you folks.
8:15-ish.
Good to meet you, Danica or
Yeah.
Danicia.
No, don't do that, you guys.
I can't do it. No. It was good meeting you.
Going
we'll
live.
Look forward to your talk.
All right. Talk to you in a while.
All right, everyone. Are we live?
We're live.
Can you hear me now? All right, welcome to this meeting of the Warren Astronomical Society. I'm Bob Trimbley, your first vice president. Our president is not going to be here immediately. She'll be in a little later, so if she actually has a president's report, she can probably give it right before we have the presentation. Election results. Well, we had an election last week, and somehow I got elected president, and we need a first vice president. Our new observatory chair is Jeff McLeod again. I believe Dale Teamy is going to continue doing thank you. I was going to say presentations, but public. Okay. So Adrian is going to continue, I believe, in the role of treasurer. And let's see, Kevin is going to continue with outreach. And Mark Kezier is going to continue doing secretary stuff. All right, so that would be the election results. Calendar sales. We still have, about 5 calendars left? How many? Anybody know what the number is?
No, we're still in double digits.
We are, okay. So if you want a beautiful WAS astrophoto calendar, we still have several left.
17.
And you can probably, if you don't want to do the mail thing, you can probably pick that up at the next Cranbrook meeting, which is also the banquet, which leads into the banquet. Our last meeting of the year will be December 5th. It will be the first Monday, our Cranbrook meeting. We've merged our banquet with that. We are going to have a speaker, Kareem Jafar, and he's going to be doing a presentation for us. Both Diane and Adrian have met him and said, excuse me, he's really cool. So I'm really thrilled to see that. And I said at the Cranbrook meeting, he also emailed me back with a whole bunch of other ideas. And one of the things that he wants to, one of the things he has presentation about is youth involvement, which I would definitely like to see increase with the club. So that is it pretty much for the, let's go through reports. Presentations. We need presentations for next year, and since I'm doing the first vice president thing still, there is plenty of stuff to talk about. And I was thinking about this. I might actually come up with a list of ideas, starting with some basic astronomy, going all the way up. And if you just want, hey, that looks good, pick that idea. So if you've got any ideas for presentations, get them to me because I can use them for next year. I am going to be hitting up some of the astrophotographers and astrophysicists and other people I follow on Twitter for things like that. I saw a couple of them today doing stuff on like exoplanet Jupiters. That sounded interesting. So Riyadh, observatory report.
Yeah, thank you. Hello, everyone. Please excuse my voice. It's not back to normal yet. Last open house we had was on October 22nd. We had a good clear sky. Unfortunately, the seeing was not so good. However, we still managed to observe many objects, deep sky objects, double stars, and at least I think 3 or if not 4 planets. We used the 8-inch refractor, plus we had some people that brought their scopes as well out on the field. And Jeff McLeod also brought his spaceship simulator as well. So we were out actually all the way until about 3:30 a.m. when we closed the observatory.
Amazing.
Next open house is scheduled for November 26th. Start at 5 p.m. because it's getting dark early now. And the final open house for 2022 is scheduled for December 17th. We moved it to the 3rd Saturday instead of the normal 4th Saturday to avoid the holidays. So hopefully we'll see everybody on November 26th and the last open house on December 17th. Thank you.
Thank you, Riyadh. Adrian, Treasurer's Report.
All right. I am scrambling, sending our new member her welcome message and link to get to our online meeting. So let's get some actual numbers here. Let's not do it like that. So we're still looking good in the treasury. I've processed 2 new memberships since I think our last meeting, and processed all of the updates that everyone wanted. Let's see if I can find my PayPal. Here we go. So in our regular checking account, we have $29,592.13. In
Nice.
PayPal, we have $465.91. And your derelict treasurer hasn't counted up the well over $500 that we have in petty cash. So you take those numbers, add the petty cash, which we're looking to deposit into, maybe deposit some of that into the Bank of America account, so we're just not sitting on a big wad of cash. And our treasury looks about the same as it's looked for the last couple of years. So any reimbursements that I've missed, or any club business money that we've spent, just let me know at treasurer@warrenastro.org, and we'll work with you on getting you anything that you need. As long as you've got receipts. And Mark, I don't know if either of us have been to the PO box, but probably high time to pay it another visit. So one of us two will get there, and so if you've sent the check, we'll take care of it within the next week. That's it for a treasury report.
All right. Thank you, Adrian. Speaking of Mark, Secretary Report, you're going to say the report's in the WASP, aren't you?
Oh. Can you hear me?
Yes.
Yeah.
Okay, good. Yeah. No, I said that the last meeting, the report was in the WASP. The only thing I have to report on is just getting all the door prizes ready for our banquet, and they're coming in some real nice gifts, and looking forward to that. And I will check the PO box, Adrian. It's been pretty slow. Hasn't been that much, but after the
Yeah.
first of the year with the membership renewals, we'll start seeing a lot more action. So that's
Yep.
my report.
All righty. Thank you. Is Kevin available for outreach? Do not see Kevin here. So
I
if
don't
you
see
have,
him, but
yeah,
I can report that the global star parties that myself and David Levy are part of started back up. And so I gave a presentation on the blood moon. And I have that presentation as well as a presentation on the University Lowbrow Astronomers McMath telescope ready to go in case you need someone to do a short presentation.
that would be awesome. My first thought when you were talking about that on both of those things, could either of those be written up for the WASP?
They could. I'll have to
Not
take
that I'm
my
tasking you that with you with that or anything, but
I'd have
yes,
to I'll
let
take
me
the
get.
PowerPoint and turn it into an article. I think there's a fairly
That
simple
would
way
be
to do
cool.
it.
Let me get with you about that, because yeah, that sounds great for presentations. If anybody has done any outreach events, please make sure you let Kevin know so he can give you credit, and we can possibly get you one of those Night Sky Network pins. So outreach. Dale, newsletter and mailing list.
Well, the newsletter is up online, and starting to work on getting our annual mailing together. and all that other good stuff.
All right.
Yeah.
Well, okay. Special interest groups is Marty. Marty does not come to these, does he? All right. So that's up to me. Let me hit share. Get over to this guy. Share screen 1. Doink. You guys seeing the sun?
On your screen, yes.
Okay, so this is the sun a couple hours ago, and as you can see, there is a pretty massive sunspot rotating into view. That's the direction it's going. This is a 48-hour video. Come on, doink, of the sun. Something very exciting going on in the upper right there, as that active region is rotating out of view, and take a look across the very top. It kind of looks like there's a crown. There's a filament going all the way across the top. So that's pretty cool. That is close to hydrogen alpha, but this is ultraviolet. This is another flavor of ultraviolet. And what's really amazing, wow, this is really being fidgety there. There we go. There is a massive coronal hole in the bottom hemisphere, the southern hemisphere there. And that is going to be facing right towards us. And that is where the solar wind just comes streaming right out. And you take a look at that hole. There's a bunch of little flares and stuff going on in there. So that is the corona. Very exciting. And I saw this on Twitter, and I'm going to have to add this into my sun presentation because I didn't even know these things existed. One of the sunspots last week was crackling not with flares, but with something called Ellerman bombs. Wikipedia has one sentence on it. They were first discovered or first announced in 1917. They're magnetic explosions a millionth as powerful as a true solar flare, but still equivalent to 100,000 World War II atom bombs. So space is cool. So that is the solar report. Go over to hands-on Riyadh. You already mentioned that you saw double stars. Have you seen any carbon stars lately? I remember Joe Toko doing a carbon showing carbon stars once.
We also do look sometimes for carbon stars. I think the last one we saw was probably about maybe 2 or 3 open houses ago. That was clear. We tried one, and we were able to see it. For the next open house, we will look at the some of the double stars that are available for us right now. A couple of them is Gamma Andromeda, also Iota Cassiopeia, and we'll also try to look for Sirius B, which we tried to look for it last time, but the sky condition was not good enough. So hopefully we will have better skies maybe this time, and we'll look for it. So we have a couple of challenging ones to look for, and one really beautiful double star to look at.
All righty, thank you, Riyadh. Dale, history.
Nothing to report there, or old for that matter.
All right. And before we get into astrophotography, Adrian, let's talk about GLAC. We had a GLAC meeting last week, and many of the officers are going poof. So if you are interested in being an officer, and there are several positions open in the Great Lakes Association of Astronomy Club and helping organize and run the Astronomy at the Beach event, we need your help. I will still be doing website stuff, but we have several officers that we're in need of. I
Yeah,
didn't know if Adrian wanted to add anything on that.
No, you said it right. We have officers that would like to step down. I'm staying on as treasurer because the transfer, basically seeing through the transfer of the funds, I opened up a Comerica account that I'm monitoring. So when I step down from GLAC, it won't include the was is no longer included in that. Everything is separate. dealing with separate accounts. But yeah, we have Jeff said he'd stay on as secretary, but I know John, our president, wants to step down. I don't know what Tim, if he wants to stay on as a VP, and Brian Ottom wants to step down as our communications chair. So there's some pretty big shoes to fill. So we need new blood for GLAC, especially since we are successfully returning. We successfully returned to an in-person event. I did not hear, and I have to mention, the COVID outbreak appeared to be no more than a couple of cases. We didn't have any others reported. So, and we had no deaths reported. So, by
Good
that
Lord.
time next year, we'll see what the new variants are and if they're even less deadly. But it looks like we are going to be back in person. So that's just, it's going to be tough, but it's going to be the way it is. And we're going to need some more input. We're going to be talking to all the clubs, not just the Warren Astro Society. So if
I am
any
going
of
to
you
write
are
myself a note.
interested,
I'm going to do an email blast to the entire membership about this.
yeah, good idea. And if any of you are interested in helping out, we would love your help. We're going to have a meeting with the current board. And I believe that's going to be the second Thursday in December. Is it, Bob? That we're supposed
Yes.
to do it?
Yes.
Yeah. So we'd love for you all to come out and yeah, be a part of GLAC. We need to turn it over to some new blood. I'll still be there. Bob will still help out until you can successfully transfer that web configurator, take care of things to someone else. We're definitely needing someone, some new blood in the GLAC. So
if you're interested in helping organize and run astronomy at the beach, I'll be sending out an email blast to the membership with meeting information. It'll be via Zoom. But anyway, moving on, discussion group. I don't know if anybody would be interested in running a discussion group this month, but I had an idea. If we can't find anybody to do an in-person hosting thing, why don't we do it virtually like we're doing right now? And it'll be rather informal because this is, formal-ish, and no presenter, just sit around kibitz because we like to kibitz anyway. I don't know if anybody would be interested in doing that, but we could organize that for sometime, next week, maybe? So think about that. We can discuss it again later on in the meeting. So, astrophotography, go.
Hello.
Hello, what you got?
Okay, so the last the last 2 weeks have been pretty crummy, plus a full moon. But late October and early November, I did get my observatory up and running with the 10-inch, which has been idle for about a year because I was using my 4-inch refractor. So I did get some shots. Let me do a share here. Okay, so one of the things I did was I went after this comet it's around 10th magnitude, comet C2020 V2. This is just four 2-minute shots stacked on the core of the comet, so it's pretty dim. Got a little bit of a tail there, as you can see. So that was done on November 2nd. Then I worked on M78 in Orion, and that was 21 by 300 second.
Wow, that's beautiful.
21 by 300 second exposures stacked. And that was also in on October 29th. In this is a interesting galaxy. It's NGC 147. on October 29th as well, and that's 51 by 300 second subs. And then I went after the Derelict group again, which is one of my favorites. That's basically NGC 7331 with the little little fleas they call them, these little galaxies around here. There's little galaxies all over the place on this.
There are.
And that was
Are those
49.
those galaxies close to the bigger galaxy, or are they more distant?
They're more distant.
Okay. Thank you.
I can.
That faint galaxy above, is that actually part of Stefan's quintet that's nearby?
That I don't know. That I don't know. Let me see. Oh no, the one above. No, that's not part of Stefan's quintet.
Okay.
Stefan's
It's not
quintet
far
is.
from there.
It's no, yeah. Stefan's quintet's only about a half a degree away. I can actually fit this galaxy and Stefan's in the corners of my chip. And I have a shot like that that I took a year or two ago. But anyhow, I focused on just the Derelict group. And then
that was with your 10-inch?
Yeah, this was my 10-inch RC. All these are with my 10-inch RC. And then this is NGC 7814. Again, 51 by 300 second subs. So over 4 hours. And this is kind of an interesting one because this is a nice little sharp edge on, kind of like a mini sombrero.
104.
Yeah, this one's 7814, but 104 is the sombrero.
God, look how far that extends out past the edge of the dust ring.
Yeah, it's quite a ways.
It is cool.
And then a month earlier, October 3rd, 4th, and 5th, I put the 6-inch on the mount and took 3 days worth of these solar sunspots on October 3rd, 4th, and 5th.
Look up.
What a mess.
Yeah, that was as they rotated towards us. So.
Wow.
That's just with my 6-inch with a white light filter.
Wow. That is impressive.
Actually, go back to the SDO and see what the magnetogram looks like on that day, because those are close together. That'd be crazy.
So, so I've got basically when I picked up that 4-inch refractor a year ago, I got the focal lengths increments that I wanted. I've got a 300 millimeter telephoto, a 735 millimeter 4-inch, a 1500 millimeter 6-inch, and a 2000 millimeter 10-inch. So those are the focal lengths I've got to work with without going to my actual camera lenses, which are a lot shorter. And that's my report for today.
Thank you. That's cool. Anyone else? Astrophotography?
Anyone want to see a couple of the images I got?
Yes.
All right. Let's see. Share screen 2. Share. Okay. So these images are going to come up and I'm just going to bring them in. This was cool. I didn't think I got this.
Oh, this was great. Great shot.
But yeah, I did
gosh, is that great.
Yeah, I did the star mapping and it said, yep, that's Uranus. And I got a little bit of the color, but like I said, when I posted this, I blew it out because I decided let's stretch the star field, and I was able to separate the eclipsed moon from the star field. So this was the moon at total. Everything's got an orange cast, but I'm thinking the moon never went deep into the shadow. It got all the way into the shadow, but this had to be the less shadowy part, I guess, if you want to think of it that way.
Okay.
When I took that photo. Let's see. So that was the surprise. And if that was a surprise, I took this one a little earlier. This is the This is the shot that the type of shot that the whole internet likes. It's the eclipsed moon, and you get a couple stars here. It was 99 point something percent because you see I have a bright limb here, so
Yep.
it wasn't entirely eclipsed, but I like it because it's a transit. It's like right before the transition happens, and you see a little part of it that still looks the way we are used to it. You see this part, and then you're in here, you're in deep shadow.
Almost like
And
you have a red Terminator.
yeah, almost like right here. It's like a gradual. Yeah,
That's
it goes
cool.
kind of like this
That's very cool.
around it. So did that. So you saw the star field. This was sort of it's kind of how an eclipsed moon looks in space. So what I did, that other shot, I cropped around here because we found out that was Uranus.
Yeah.
And there's these other stars that were surrounding it. So that's always a cool look. And then
Anybody
go
at the
out
International Space Station get a shot of that?
I don't know. But this was the
I'm gonna
moon
find out.
before, and the site I went to before it was fully eclipsed, and all of this was showing up. This was a non-modified camera, and at the site that I went to, all of this was showing up in the sky. The
It's crazy.
the modified camera image. This is a 30-second image here. I managed to catch a couple of meteors. There's one shooting right through the California nebula here.
That's a good image.
Nice.
There you see the eclipsed moon. And because
Great
I
images.
used my modified camera, I got a little more detail.
Is that
I do
Mars
believe
on
this to
top?
be sky glow here. And this was during astronomical twilight was beginning. I took the shot that got shared by David Eicher is this one. It's cleaner, no meteors. Somehow in 2 minutes I got no meteors. All of a sudden, moon's more eclipsed here. And,
Was that a meteor or satellite, Adrian?
the one was a meteor. I'll go back to it. Now, these, it could be satellite. That could be a satellite there. But this, the reason I know it to be a meteor is just its trail. And this is a processed image. The initial one was a lot cleaner line. When the trail grows in intensity, you know you got a meteor. When the trail is fairly solid, like this one, can't really tell if it's growing in intensity. Over here, it's pretty much the same. So it's either satellite, either geosynchronous satellite or a plane. Most of the time, planes have dots. Yeah, you got something else up here. So that was in 30 seconds, which it's interesting that in 2 minutes I wind up nothing. Well, I get this line right here, which appears to be a satellite to me. Some meteors, depending on if they streak across the sky with a consistent, brightness, they look like satellites when you look at your image, but in fact, they actually are meteors. And so I did have a successful trip, although it was tough. A couple of other, and I didn't mean to show this one quite. Interesting enough, here you have the beginning of, the end of astronomical dawn, the beginning of nautical dawn. That's the appearance the sky had. And that was interesting to watch too, because as it got brighter, the surroundings got brighter, but the moon remained eclipsed. And then
Mars was
finally,
up at that time, wasn't it?
yeah, say it
Mars
again,
was
Ken.
up at that. Mars was up at that time, wasn't it? It was real
Yeah.
bright in the middle of the sky. Okay.
Yeah, Mars was up. Yeah. There's Mars.
Yeah, that's what I thought. Yeah.
Yep, there's Mars during totality. So
Yeah, that picture of the trees, that's what I saw.
Yeah, this is the
Went outside, and that's exactly what I saw right there.
last vestiges of eclipsed moon, as this is it moving out of Earth's shadow.
Right.
So the eclipse is beginning to end, but this is civil dawn. So the one thing I did not see was a transition from the moon's color going, bright to the usual Raleigh scattering that happens that colors it red. The difference with the eclipsed moon's Raleigh scattering and the Raleigh scattering we see at sunrise and moonrise and moonset is that the sun shoots direct light on the moon. It's brighter. The sun's light is indirect during an eclipse, so it's a lot dimmer. So that affects the color of the moon.
Sure.
And I called it quits after I took this picturesque shot. This is the same thing. It's the entire Au River, 3 hours away. It's not far from where the Great Lakes Stargaze is. It may be under maybe 30 minutes away from here to the Great Lakes Stargaze.
That's the Asabo.
Yeah.
Au Sable.
Station.
Yes.
Asabo.
Okay.
AUSABLE.
All right, so it is
That's
8
it.
o'clock, and this is typically when we take a break. Our speaker is going to be coming back about 8:15, so we'll start around 8:15, 8:20-ish. So take a break. If you want to continue kibitzing and showing astrophotos, that would be just fine. But the program will resume around 8:20.
My son, my grandson and I went out to see the eclipse. I picked him up early, and we went out and we went over to a park, and a police officer came by because it was a baseball park or softball park anyway. And he says, what's going on? And we had to tell us. And I pointed to the eclipsed moon, and he went, "Whoa!" That was so cool. Whoa! And I said, "Well,
Hey, Ken, you didn't tell him you didn't tell him you arranged the eclipse for your grandson, did you?
No, and my grandson would have told on me anyway. So if he's smart, he would have, And we really had a nice time. And then we went over to another. And then just as it was about to get completely eclipsed, all the lights went on in the park.
Oh.
Everything went on. And I'm saying, what the heck's that all about? So we moved over to another park and were able to see the rest of it. But it was great.
You hit
He's
nautical
17.
twilight.
Yeah.
That was around somewhere between total eclipse and end of astronomical twilight, nautical twilight. All of that happened. So those things are on a timer.
And as far as outreach is concerned, just to mention a couple of things, I've told you before, I'm posting on Facebook once a week on Wednesdays, Astronomy of the Week, and I've done a lot of the constellations more recently. I've done all the interesting objects and such, explained them, and so on and so forth. And I'm getting more and more people that are signing on and asking questions, which makes it more fun to do. And this last week, I actually did one on Halley's Comet, or Halley's Comet, if you want. And I must have had 20 responses on it, which is pretty darn good. And every week is something else. And that's what we're going to keep doing every week.
I got some planetary images to share I got in the last couple of weeks.
Okay.
Go for it. I'm going to
go for it.
Do it.
We're in.
I did share them at the last meeting, but
oh, that's wonderful.
This might be a better venue because it's easier to see.
You lost the moon.
On big screen. So
you lost the moon.
3 moons. There's a close-up of Jupiter. I think this is like my best Jupiter ever.
It's pretty
Seeing
damn
was
good.
pretty decent. Must have had my collimation pretty well intact. Got my process down. This is with an 11-inch.
Very nice.
I did buy 2 new cameras this year for Planetary, so that helped a little bit too. But I think the seeing is the bigger factor.
Sure.
And I got my best ever Mars.
Wow.
Oh gosh, that's a great
This
shot.
is a lot better than last time.
Dale, that's really spectacular. Great job. Wow.
Yeah, this was from November 2nd, I think.
Okay.
So I'm
Look, I can
hoping
see
to
the
get
canals.
some more clear skies to get it during opposition. It'll be a little bigger, and we'll get the full thing here.
Yeah, I can
What's it
show
go-
everybody why we don't have clear skies. I'm holding it in my hand.
Right.
I have a
Just
new
got it today.
SQM
Oh.
meter.
Cool.
Yep. Now I get to see just how dark some of these places I travel really gets.
That is cool.
The final thing I got was the double transit of Jupiter. We talked
that's
about that
cool.
last time. This is Ganymede here. This
And that
one
should be-
is Europa, and this is Io over
Yeah.
here on the left. But I caught it just as Ganymede was coming in and going out,
Right.
and I did an animation.
Look great. Oh, good.
It's 18 frames.
Oh, that's great.
Is that showing up okay on the screen?
Oh, that's spectacular.
Yeah, it is.
That's really great.
You
Wunderbar.
don't often get to see a double transit.
No, you don't.
I've never seen a triple.
Both of the shadows are in the southern hemisphere.
Right.
So that would mean that Jupiter, Jupiter doesn't have much of a tilt at all, does it?
No, it doesn't.
But some of the moons they're not all necessarily on the perfect axis, are they?
No, they are not. You're right. Correct.
Okay.
Ganymede's below it, and Europa's a little above it. Io kind of goes through the middle often enough. Io is the closest one. It's as close to Jupiter as our moon is to us.
Hard to believe that beautiful ball of gas would kill you if you were near it.
Yes. Irradiate you to death.
So there would be some angle of the Earth above the ecliptic,
Right.
and Jupiter could be slightly below, or
Right.
at some other angle, which would help to skew these a little bit. Of course, their shadows cast by the sun, and so yeah, there's angles involved there. So it's an interesting observation. I'm not sure, but yeah, you're right. They are definitely in the southern hemisphere there.
Right.
I am surprised that the shadows aren't going right along the equator. I was unaware.
No, they're not.
All of the models I've seen, they're pretty much flat. You know, they could be in Saturn's ring. They're so flat, but I was unaware that.
You know, like when we're looking at Mars, aren't we looking kind of at the north right now?
Yeah, that is the north.
Does our being in the winter and the angle of the Earth tilted have any effect on that where we can see it?
Not particularly. Mars, that's the larger of the two caps is the northern cap. So that would be the northern cap right there above. You can see it. It covers quite a area of thing. The southern cap isn't anywhere near as big.
So I've seen pictures of Saturn through the years, and that has a cycle where, you know, the angle of the rings relative to our field of view, looks like it tilts down and back up and back down and back up over the years.
Mm-hmm.
So
that is a little better tilt than the other ones do, by the way. So
I've taken some deep sky stuff, but I haven't processed it. It's been a couple weeks since I took it. I'm not even sure what I got.
So I just posted a link to NASA's web app, and the 4 Galilean moons are absolutely in a flat plane around the equator. Well, okay, I'm not saying this is accurate. Okay, this is just for general public consumption, but yeah, they're in a flat plane. And they also that flat plane syncs up right with Jupiter's orbital plane. So something's got to be off. So I got to go do a little research.
then it must be, our
Well, I'm not saying this is representing
position
it
that
right.
we see them. I've have other images of Jupiter where they definitely don't look lined up.
What was the date on that? I can actually set the date on this thing. Pause.
Yeah.
What was the date?
Double transit was November 3rd
November 3.
at this is UTC time.
Oh God. Well, I can backdate it. Doink.
40
I think
minutes after
Jupiter is
midnight.
right on the ecliptic, though.
After midnight. All right.
I think that Jupiter's right on the ecliptic. Right on it.
But sometimes when you see the four moons, they're not in a line. Eo's up and Callisto's up or whatever, and it's probably just their orbital position.
Right.
But we're not looking at them straight on, though, either.
Yes.
So if you look at doesn't the Earth go above or below? Kind of like Pluto. Don't they all the planets do a little bit?
A little bit, yeah.
The tilt of the axis of Jupiter is only 3.13 degrees.
Okay, yeah.
Okay.
Not much.
That's the tilt. 3.1 as opposed to ours, which is what, 24 or whatever it is?
Oh, I got the shadow. Look at that. Playing with this thing at that date, I actually got the shadow of Io on. It was that wasn't Io. It was Callisto.
Ganymede and Europa.
Oh, so I got Io. So let's keep going.
So I do it in Stellarium to see what what things are going to look like.
There we go. Yeah, I've done that as well.
Here's interesting. Saturn's tilt is 26 degrees, and ours, of course, is 23. So it's tilted a little bit more than we are.
What's Mars?
I can tell you that. I don't think Mars has much of a tilt. Hold on. I'll look it up. I think that Mars has, Mars' rotational period is the same as ours, pretty much. 25%, 25 degrees. So it's the same as ours, approximately. Okay. About 20, that's what it says, 25 degrees. It's virtually the same as ours. Its day is the same length of time, it's 24 hours. But that means it's spinning
Jupiter
a little.
is sort of an outlier, and Uranus is an outlier for being really weird actual tilt.
Oh, yeah, I got to share this. I saw an interesting post. Here it is. Mapoftheuniverse.net. Posting this in chat. This is an interactive map of the universe from You Are Here going all the way to the CMB, and it is pretty cool the way they represent it. How many of you guys are familiar with Wallace and Gromit?
I don't know.
Yeah, it's
Yes,
their
I know.
stop motion animation characters from Aardman Studio, which is in Britain. But in one of their movies, one of the characters is Shaun the Sheep. Well, Shaun the Sheep is on Artemis with an ESA coverall. He is the spokes sheep for the ESA, kind of like Snoopy was for the Apollo missions. So that's pretty funny. But Shaun the Sheep Twitter feed is all about this, and they've got a patch for the Sean and the Moon here. Now they're really milking it for everything they can.
Here's another thing about Jupiter. Jupiter's got an inclination to the ecliptic of 1.3 degrees. I'm trying to figure out whether so it'll go up and down, I guess. 1.3 degrees. Does that sound right?
Well, what we want to see would be the inclination of all the Galilean moons to Jupiter.
Yeah, that's a good point. Okay.
You're right, Bob. I'm looking at your link there, and the Galilean moons do look spot on, but it doesn't take much tilt from the ecliptic for the moons to start to look above and below.
Right.
Less than I thought, really. So if you just tilt it down like 1 degree,
a couple of degrees, and then you put the orbit of the moon way out, its shadow is going to be in the southern hemisphere.
So the farther out,
yeah.
So Io being the closest in,
right?
The shadow is closer to the equator, just because of distance. So I could see that Callisto. There might be times when it might not even cast a shadow, or certainly it'd be further.
It might be. Yeah, it's way out there. Yeah.
Let's
Talk
see.
about a 1 degree tilt, but you put that thing how many millions of miles away is that?
For what? What are you talking about?
Callisto. How far away from Jupiter?
Callisto is. Let's see. Callisto is 1.8 million kilometers. No. I'm sorry. What am I talking about? That's its orbital radius. That's not what we're talking about. The distance from. Hold on a second.
Oh, that's right. Callisto's orbital radius would be about Jupiter.
Right. There you go. That's correct. That would be
a million something kilometers.
Almost 2 million kilometers. Because Io is 421,000 kilometers, so that's the same distance as the moon is from us, approximately, ballpark.
There's some of the moons of Jupiter on some of these 3D apps, like this EYES app. You turn on the minor moons, and it just overwhelms you with orbits around Jupiter, and it just amazes me that some of those tiny little moons can take like 2 years to orbit Jupiter. That's just crazy.
And you talk about Io, that takes 177 days to get her. 1.77 days to get around Jupiter. 1.77 days, and
doesn't Io have something to do with the patterns in Jupiter's clouds? Doesn't it have some effect?
It would, because they're blowing off all kinds of stuff. That sucker. That's a lot of. It's volcanic entirely, and some of that.
Well, no, I'm talking about it causes churn in the atmosphere.
I would not be surprised, being as close as it is.
I know. It's got. I know that when they look at the aurora, there's a weird dot that orbits. That's related to the electric field and Io. It's crazy.
Wouldn't be surprised at all.
Crazy.
Absolutely.
Jupiter
the orbital
is so
radius
weird.
of Europa is 671,000, so it's about 1.5 times farther away from Jupiter than Io is, and Europa has a 3.55 day revolutionary period around Jupiter. Even Callisto takes 16 days.
Okay, we're coming up on 8:20. We're going to be starting our presentation pretty soon.
Cool.
In a minute. Danica, you ready?
Good to go. Hey, Bob.
Hi there. All right, give everyone a second to get back into their seats and get ready. I'll start at 8:20. So welcome back to this meeting of the Warren Astronomical Society. Our main speaker tonight There we go. Might as well start that right now. Our main speaker tonight is, see if I can get this right, don't want to screw it up, Danica Remy. Okay, I'm not going to say the one you've mentioned earlier because yikes, I will mess that one up. She is the president and chief executive of the B612 Foundation, which leads the private sector efforts in research analysis, systems design to protect the Earth from asteroids. She also co-founded the international program Asteroid Day, along with legendary Queen guitarist Dr. Brian May, who has a PhD in astrophysics, by the way.
Yeah.
And Apollo 9 astronaut and B612 Foundation co-founder Rusty Schweickart, and German filmmaker Grigorij Richters, I believe is how you pronounce it. Asteroid Day is sponsored by the Government of Luxembourg and international space agencies, and the 2016 United Nations sanctioned it as an official day to decrease or to increase global awareness of asteroids, and that day is June 30th, the day of the Tunguska blast in 1908. In this session, Danica will describe the functions of the B612 Foundation and the research going to defend our planet from asteroids. And she'll probably be mentioning the DART mission, which, look behind me, that's Dimorphos. So take it away.
Well, thank you so much for inviting me
Right.
to come talk about our work. I love being able to do these kind of sessions all around the world. So thank you so much for the introduction. I'm always delighted to talk about asteroids. As you know, you mentioned, Bob, asteroids present both an opportunity and a challenge for humanity. And asteroids are interesting celestial objects that can tell us about the origins of life on our home planet and nearby objects to visit and demonstrate new technology and stepping stones along the way as we move out towards other planets. So let me give you some background. B612 Foundation and our Asteroid Institute, the organization I run, is dedicated to protecting the planet from asteroid impacts. And we do that through primarily science and technology and a bit of education and advocacy. So before we go into what we're doing, let's start with how often our planet gets hit by asteroids.
Are you sharing right now? Because I'm not seeing anything.
Ah, well, I guess I forgot to hit that button. Hold on.
Okay.
Can you see it now?
Yes.
Great. Great. Fantastic. Fantastic. So, our work is primarily science and technology and a bit of education and advocacy. And so I always like to sort of set the stage to kind of understand why this organization was initially formed, dedicated to protecting our planet, and put into perspective how often we get hit. So we worked really hard with Google and some scientists to get some data released so that we could create this video that we released on Earth Day. So I'm going to, hopefully you all, the lag won't be too bad, but here we go. Whoop.
The Nuclear Test Ban Treaty Organization monitors the Earth around the clock, listening for the infrasound signature of nuclear detonations. Between 2000 and 2013, this network detected dozens of massive explosions in our atmosphere. But not a single one of them was caused by a nuclear weapon. The actual cause, asteroid impacts. Between 2000 and 2013, there were 26 recorded asteroid impacts on Earth, ranging in energy from 1 to 600 kilotons. For comparison, the nuclear bomb that destroyed Hiroshima in 1945 exploded with an energy of 15 kilotons.
So much for clearing its space, huh?
While most of the asteroids shown here exploded at too high an altitude to cause damage on the ground, they do remind us that asteroid impacts are not rare. An asteroid large enough to destroy an entire city hits the Earth on average once a century. Because we don't know when or where the next major impact will be, our current strategy for dealing with asteroid impacts is blind luck. But we can change that. The next great space mission is protecting the planet. Join us.
So wow, right? I mean, there's a lot of bullseyes on our home planet. So let's put a recent asteroid impact into perspective. In 1908, an asteroid exploded in the air in Siberia, Russia, near Tunguska, which you talked about, Bob. And it's the largest recorded asteroid impact in recent history. That asteroid devastated an area about the size of a metropolitan area, about 800 square miles. This is a photo of the trees that were blown down by that asteroid when it exploded in the air. It didn't hit the ground, it exploded in the air. And the shock wave and the heat from that explosion was felt all across Europe. Had that asteroid hit just a few moments earlier, say over London or Berlin, it actually would have been a defining moment in history. So how many of these near-Earth asteroids are there? The Minor Planet Center, funded by NASA, keeps track of the near-Earth asteroids and has a database of 30,000 near-Earth asteroids today. So we don't care about the asteroids out in the main asteroid belt. We care about the ones that come near our home planet. So let's look at the data. By starting in the far right top bubble, the good news is that NASA has found 93% of the civilization-ending ones, and that none of them that we know about are on the way to impact Earth. So we won't go the way of the dinosaurs. This size of asteroid is the kind that would wipe out all civilization and were largely inventoried back in 2010. Now let's look at the circle with the 44 to 140 number. Today we've tracked 1% of the 1908 Tunguska-sized asteroids or larger. That's the one I mentioned that wiped out all the trees in the prior photo. An asteroid of that size, if it hit in the wrong place, could devastate a population and destabilize the world economy, and much more. So today's telescopes find about 2,000 new near-Earth asteroids per year in all size ranges. And at the current discovery rate of 2,000 per year, how long will it take to find 500,000 or 3 million near-Earth asteroids? It's a really
Entire
long
length of
time.
human civilization.
It's a really long time. Discovery is really humanity's grand challenge with this existential threat. So the really good news is that there's a new telescope coming online and will be really good at finding asteroids. Formerly called LSST, but recently renamed the Vera Rubin Observatory, first major observatory named after a woman. It's situated high in the mountains in Chile, and it will see first light in a couple of years. This telescope was first funded by individuals. I should say B612 is completely funded by individual donations. We received no government support. And the bulk of what was funded for Vera Rubin was funded by the National Science Foundation and the Department of Energy. Its primary objectives are to understand dark energy and dark matter and survey the Milky Way, but it will also be really good at finding asteroids. Vera Rubin's telescope will complement the current land-based telescopes like Catalina Sky Survey in Tucson and Pan-STARRS in Hawaii, which those two telescopes currently find the majority of the 2,000 near-Earth asteroids annually. So remember, we have an inventory of about 30,000 today. In just a few years, next year, the end of next year, the beginning of the following year, Vera Rubin will see first light. And it is anticipated to deliver about 200,000 new near-Earth asteroids within the first year, dwarfing the current inventory. So I like to think about that we're entering the age of asteroid discovery, a decade of asteroid discovery, actually. So once we know where an asteroid is, we need to actually understand its orbit. So we need to simulate all the force factors in space to find out where an asteroid is going to be in the future. And we need to know if that asteroid has our home planet's address on it. So that task is what is called orbit propagation. At B612 and the Asteroid Institute, we're building a platform that creates these orbit propagations and more. Our Asteroid Discovery Analysis and Mapping, or ATOM for short, platform is building analytical tools to help world leaders, scientists, and citizens in the future interpret, understand, and manage the fire hose of new asteroid data that's going to be coming in this next decade. The long-term goal of ATOM is to enable and serve up a dynamic map of all of the objects in our solar system. So to build ATOM, it really requires partners. Google gives us really the computational power. Thank you, Google. AGI provides a baseline mission planning and astrodynamics tools for us to think about how we'll build this map for the solar system, not for low Earth orbit, where AGI does most of their work. And the Vera Rubin Observatory will provide data along with the other smaller telescopes that are coming online. So let's take a look at what ATOM can do today. Our platform can easily and conveniently, for those people who are uber geeks, propagate and visualize a range of trajectory possibilities for an asteroid. Such calculations, called Monte Carlo simulations, involve running forward many thousands of slightly different trajectories that are each nevertheless consistent with the observations. These calculations would not be possible without the new computational capabilities from computers and cloud computing. We like to think of this as like significant progress. Thank you, Moore's Law. We are getting better at calculating. So by looking at how these slight varying cases diverge, we can calculate the critical parameters such as probability that a certain asteroid might impact Earth. Now, this is just a single simulated asteroid, not real, and each one of the red dots you are watching were possible impact sites. We would need more observations over time to understand more precisely if it were actually to hit or miss our home planet. So that's why we need both ground and space-based telescopes to do what we call follow-up observations, as well as initial discovery. So once we know where they are, how would we deflect them? One of my colleagues, three-time astronaut Dr. Ed Liu, along with another astronaut, Stan Love, invented the gravity tractor back in 2005. The gravity tractor uses the gravitational interaction between a small spacecraft and an asteroid to tug it into a different orbit. One of the other deflection techniques is the kinetic impactor. Essentially, you kick or knock an asteroid into another orbit by smashing a small spacecraft into it. So now the good news is that NASA and ESA have two missions funded called DART and HERA. DART, short for the Double Asteroid Redirect Test, recently crashed into an asteroid and was a smashing success, pun intended. And we'll talk more about that mission when we get to the end. So after the DART mission crashed into the small asteroid, which is behind Bob, the HERA mission, funded by the European Space Agency, will arrive and take photos and measurements and look at the impact crater afterwards. So one of the things that the Asteroid Institute is looking at is the amount of energy that it takes to move an asteroid. The energy it takes to move an asteroid depends on how early we find it, which equals how much warning time we'll have. So the more time you have, the smaller the kick you will need, and therefore less Bruce Willis. So global progress is being made on these deflection demonstration missions. Essentially, which is fantastic, you can't say this about a hurricane or a tsunami or an earthquake. Essentially, the scientists agree that if we have enough warning time, we have good solutions. I have the honor of working with a lot of astronauts, and they really understand asteroids' risks as well as their opportunities. My colleague, former astronaut Dr. Ed Liu, who leads our Asteroid Institute, took this photo from one of his 3 stays on the International Space Station. This is the San Francisco Bay Area. Not sure if you can see it very well through your browser. If you could pick out the Golden Gate Bridge over there on the left, I'm about 10 minutes north of that bridge right now. I love these kinds of photos of our home planet. They always inspire me. And Ed took this photo while he was on the space station. And we always like to joke with Ed that he had a very, very nice view from his former office window. So here is Dr. Ed Liu explaining our place in the solar system.
This is our solar system. We live on the third planet. That's the light blue line you see near the middle of the screen. Orbiting the sun besides us are millions of asteroids. In the outer part of the screen, you can see the asteroid belt. That's between Mars and Jupiter. In our neighborhood, in the inner part of the solar system, there's a lot of other asteroids that are whizzing past us. Showing here the 10,000 known near-Earth asteroids. These are the asteroids that cross near Earth and occasionally hit the Earth. It's 10,000 of them that we've discovered thus far.
There's actually
Seems like
30 now. This is an old
looks
video.
like a busy place. Until you realize that we've only discovered about 1% of what's out there. We've only surveyed about 1% of the sky. There's about 100 times more than this actually out there. The real solar system looks something more like this. A million asteroids orbiting near our orbit. We're driving around with our eyes closed. Our job is to find these asteroids before they find us. Because if you don't know where they are, there's nothing you can do about it. If you know where it is, we know we can deflect an asteroid. That's what we're trying to do.
Generally, folks say, wow, when they see this video. I'm not sure how it looked on your end. Might have looked just like pea soup, but you all get the idea. So I hope you've now learned that the core challenge for planetary defense is that we need to find and track the asteroids. We need to accelerate the rate of asteroid discovery. So 8 years ago, as you were saying, Bob, when we started off, a small asteroid hit in Chelyabinsk, Russia, which sent 1,500 people to the hospital and blew out over 100,000 windows. And we realized that we needed the general public to be educated about asteroids. So we launched Asteroid Day to enable and encourage the world to learn about asteroids, like we're doing here today, like Bob has been doing and the observatory has been doing for several years. Thank you so much. To pressure governments and industry to accelerate the investment in discovery and get involved. Dr. Brian May, as mentioned, you know him as a rock star, and my colleague Rusty and my film colleague Grigorij Richters and I co-founded Asteroid Day. And Asteroid Day is now a United Nations Day of Education and Awareness, celebrated on June 30th. And we modeled it after Earth Day to have it, to make it kind of open source so anybody can host their own Asteroid Day event. So here's what we've done so far.
Who better to rock our world than Dr. Brian May, astrophysicist and legendary guitarist of Queen, who co-founded Asteroid Day. Asteroid Day Live is the only programming dedicated to introducing you to many of the most prominent asteroid experts in the world. We learn by listening to them share their personal experiences and knowledge of how our solar system was formed, how it is evolving, and how we can protect our beautiful blue planet. But this programming wouldn't be possible without the generous support of major sponsors, including the Government of Luxembourg and you. You play a critical role in our ability to shine a bright spotlight on the leading work of astronomers, engineers, scientists, space mission operators, and astronauts, our global rock stars, who bring the topic of asteroids closer to people of all ages and remind our government leaders of the importance of funding planetary science. Asteroids play an important role in our lives, from the formation of our solar system to their extraordinary value for future resource utilization, to enabling ongoing exploration of our solar system, and finally, when they impact our home planet. Asteroid Day is more than just a broadcast program. It's thousands of independently organized events in 192 countries. These events are the heart and soul of Asteroid Day, as they connect and engage students on the subject of asteroids. For many students across the world, Asteroid Day is their only opportunity to listen to, learn from, and to meet astronomers, astrophysicists, and astronauts. heroes of the STEM generation. Your support enables the growth of our network of independent event organizers, so more events can take place. It allows us to not only encourage the future generation of scientists, but to grow our online library of educational tools, enabling more people to dig deeper into asteroids and to connect to scientists, observers, and astronauts. Your support enables us to meet the goals of the United Nations Office for the Peaceful Uses of Outer Space Affairs by generating awareness of what we can do to protect our planet.
So education is key, and that's why I'm here today speaking with all of you. So before we go to Q&A, let's talk about really amazing progress this last year. As you know, the world, as you sort of have seen, we're making good progress through education and awareness. And B612 is, proud to be a founding partner of Asteroid Day. But B612, the organization that I run, actually has been around for a long time. It was founded 20 years ago with a mission to see that an asteroid deflection mission happened within 15 years. That was our original goal when this organization was formed. Our early role was educating and advocating in Congress and at NASA and in the media that the world needed to pay attention and work together to ensure that we had tested a deflection strategy before we find out that an asteroid has our address on it. And we were thrilled that NASA, working with scientists and engineers around the world, did just that this year with the DART mission. At B612, while we were not directly involved in the DART mission, we have been asking the world to invest in this mission or a mission like it for 2 decades. And this year, our founding goal was realized this September. So let's watch a really short clip of a marvel of human capability. So for those of you who don't know, SpaceX, this was SpaceX's first interplanetary mission. So they launched the DART spacecraft. This happened on, this is the last minute and a half before the DART mission crashes into this asteroid. And it's what's quite fundamental about this is that the scientists and the public saw this all happen at exactly the same time. That image, that last image, that was shared success with all of us, for the scientists, all the mission operators who were on it. That shows that we, when we work together, can actually make significant progress. So we're incredibly proud of that work. And while DART was an amazing feat of engineering, science, and humanities ingenuity, we are all proud of this mission, and we're going to be learning really important science from the DART mission and the follow-on mission from Hera. We have the tools, if we invest in them, to protect our planet. So in closing, this is a global existential risk. There is a global existential risk of asteroid impacts, and it is solvable in our lifetime. The world needs to understand both the risk and the opportunities asteroids present. And our B612 Asteroid Institute are working on some of those solutions today. And global space agencies are funding asteroid deflection and research missions. And scientists are learning more about asteroids with each new scientific mission. And there's several other exciting ones on the runway to head out into our solar system. And there is scientific agreement on how we can protect our planet. In closing, to protect our home planet, we need to know where the asteroids are and whether they're heading to our address in the solar system. Otherwise, we are flying in the dark. I look forward to your questions. Don't make them too technical. I'm not a scientist. Over to you, Bob.
All right. Well, so first of all, tell them where the name B612 came from.
Did any of you read the lovely book called The Little Prince? It's one of the best read children's books in the world.
I just posted a link to it in chat.
He lived on an asteroid, and it was called B612. And so when this organization was formed 20 years ago, I'm just outside of the Johnson Space Center. I'm at Ed Lu's house with Rusty and an astrophysicist by the name of Pete Hutt and a planetary scientist by the name of Clark Chapman. Late at night, after having too much beer and wine, they said, in order to publish research papers, we're going to need an organization. And they said, okay, we'll form a nonprofit. And then they said, what will we call it? And one of them said, what was the name of the asteroid that the little prince lived on? And Pete Hutt said, I don't know, but there's this thing called Wikipedia. Let's look it up. 20 years ago, let's look it up. And there on Wikipedia was the answer, B612. And so that's how we got our name.
So yeah, so many of you know that I play, and Jeff McLeod play Kerbal Space Program. And one of the things that the B612 Foundation did is they had a collaboration with Kerbal Space Program, and there are missions in the Kerbal Space Program now to find and deflect asteroids. And when the B612 when I found out about them, they had a plan for a space telescope, a infrared space telescope called the Sentinel. It's an asteroid hunter, and there is a Sentinel-like space telescope in Kerbal Space Program, and there are missions to put it in an orbit between the Venus equivalent and the Earth equivalent to look for asteroids. So that is pretty darn cool that collaboration happened.
We released that, so I won't say we, but they released that on Asteroid Day in 2016. And our foray into the developers who are working on that program is someone by the name of Scott Manley. I don't know if anyone here watches Scott Manley on YouTube.
That guy's awesome.
He's awesome. He's one of our, most a really good advocate for our work. We love Scott. He lives over
And
that
he's got
Golden
a
Gate.
great accent.
He does. Fly safe.
So I said I found out about the B612 Foundation about shortly after the Chelyabinsk event, because I kind of went nuts, and I was just like, oh my God, this is I found out about asteroids from Carl Sagan in 1980 as on Cosmos, and yeah, I found out about Tunguska then, and when I talk about asteroids to school kids, I ask every one of them, any of you heard of Tunguska? And they're like, no, and I'm like, you're gonna. And the pictures of the flattened trees, and I created a graphic showing, it's flattened area larger than Washington D.C. It's pretty darn scary, and I didn't want to see that happen again. So I was asking Danica earlier that Chelyabinsk happened over the Chelyabinsk event happened over a Russian town. I saw the next day that they estimated the damage at $30 million. I never saw another number, and I don't know how they came up with that so short after it happened. But just think about if that had happened over New York and 20% of the windows had gotten blown out and 5% of the buildings had some sort of damage, what would those insurance costs have been? It's just mind-boggling to think about.
I'm an insurance guy. A lot.
A lot.
A lot. I had a question for you, Danica.
I want to comment on it though, that if it had hit a major city here in the United States or in Europe or Asia, we would not be having our cup out asking for funding to build the tools that we're building. We would have been funded.
Yeah, I guess. My question for you is, you were talking about the number of asteroids that are going near us, if you want to call it that, and that big thing that you were showing. How many of those asteroids have they determined are of real danger because of their size?
I I put a link
I
in
would-
chat. The CNOS, JPL, NASA, the Discovery stats. The first thing you're going to see if you go to that page is the discovery curve, which is practically exponential, and it's
Okay.
freaking scary.
Okay, so
But Jim, you have a question?
Yeah, I put it in chat, but I wonder if Dana could comment on the compromise of the Vera Rubin's mission. One of its main missions is to discover and track and give us orbital information about asteroids. How much has been compromised by the increasing orbital light pollution problem?
So I'll do that one next, but I did want to point out that one of the reasons that we did this graph that I've shared again with you is that when you look at that graph that JPL puts out, the average person does not know how to interpret that. And so that's why we created this graph to sort of say, yes, they are exponentially finding more and more asteroids through Pan-STARRS and Catalina Sky, but there's a lot more that we really do need to find.
That's
and
what I was
so that
asking.
exponential curve looks great, but not if you don't have the context of how many are actually out there.
What I'm saying is that what was the assumption of how many there are? Not, I see your point of 1,000 like that, but that's just estimated, or is that what they know of? Is what I'm asking. You said 1,000 near Earth astronauts in this size range of over a kilometer. How many do they assume there are? That's what I'm saying.
These are the assumed numbers. So we use Alan Harris's model. I don't. The scientists on my team do, to come up with this. I mean, I think that one of the things that we'll learn with Vera Rubin is, whether or not those models were, over or underrepresented. I mean, this is all very new science for everybody, right?
Exactly.
Yeah.
Thank you.
Yeah. So on the Vera Rubin and light pollution, I think it's a complicated situation. We work very closely with what's called the LSST team. So that's the Legacy of Survey of Time and Space, which is the data pipeline that's going to come off of Vera Rubin. So our engineering team, we fund the scientists at the University of Washington who are helping us build the algorithms to be able to sort through that data. I don't know if anyone, and I didn't put it in here, but in May, we had a front page cover story on the New York Times science section that our algorithm is now able to sift through old data to...
I saw that.
Yeah, we're very proud of that. Very proud of that. And so you're going to see more things coming out of B612 and the Asteroid Institute in advance of Vera Rubin that are all computationally based. What we hope will be useful success stories that'll help us on the asteroid discovery side of things. We do have a website. It's called. You can go to our website b612foundation.org. There's a link to Atom. The way to think about what we're building, I'll get back to the thing about the light in a second, but the way to think about what we're building is that we're building an engine with our partners at Google and our partners at UW. And that engine has open APIs and all of our algorithms are open source. So for us, it is incredibly important that the mathematical models that we use to say whether or not an asteroid is there, where it might be going, where it was in the past. We want scientific debate and mathematical and physics debate about whether or not we've properly done it. And so what we're doing is a little bit different than what, places like JPL or ESA are doing, because we are basically saying, check our math, have a look at it, right? Very open and very transparent. So we're building an engine that can run these very complicated algorithms. And the best way to think about it is that we're enabling a space map. We are not the space map, but we have an engine that will enable a space map in the future. And people will put services on top of this engine to help build out our understanding of our solar system. So think of it this way. Google was just a bunch of maps when Google Earth came out. Then they had open APIs, and then people started building tools on top of it. So think of it as Zillow and Yelp and Uber. That engine of Google Maps enabled all of those businesses. So we believe that, with Atom, what we're building, we're going to build some services right now for our needs, which is we want to protect the planet from asteroid impacts. But we know that the astronomy community is going to come and build more tools that we can't even imagine right now, on top of this platform or this engine that we call Atom. And so, we work really closely with the folks at UW, which run the data pipeline for Vera Rubin. So I wanted to say that because that was a lead into your question about space, the light pollution. It depends on who you talk to right now. There's a lot of things that can be done computationally for, the removal of some of the light streams that come across, particularly when first light is coming up, and then you see these satellites streaking across their observation. So I think the jury is out. Certainly, the press is really excited about talking about the negative. And that there's a big problem there that's being presented by the space industry. I think we're not really going to know the answer to that until we get past first light. But they are definitely working on algorithms. The Vera Rubin and LSST team are definitely working on algorithms to help clean out that pollution in their observations. Does that help answer the question?
Yeah, it does help. Thank you, Danica.
I can only see that kind of stuff getting worse. So you're going to have to, keep working on that and improving it, because Jim gave a presentation recently, and there's more and more constellations of satellites going up. So
Yeah.
it's going to be a problem.
No question. No question. And it already is. It already is.
Well, it seems to me, Danica, that part of the problem is raising the visibility of the possible dangers of a Earth shattering collision. And one of the biggest things of the LSST, or the Vera Rubin, is going to be to by orders of magnitude identify more and more of these potential problems, and compromising that seems like ought to be given some kind of priority.
Yeah. So I know so the algorithm that we announced, which is Thor, trackless heliocentric object recovery, is actually going to be a core way potentially to open up Vera Rubin's ability to actually not have to work so hard against that. I think it's the fourth science objective, which is asteroids, because we were able to, through our algorithm, actually link together data, separate observations through all of these different data sets that we knitted together, just like Google Earth knitted together all this Earth imaging. So we're hopeful that that through computational capabilities, we'll be able to do a lot of asteroid discovery off of the Vera Rubin pipeline, and they're kind of counting on us to prove that we can actually write great code that will make asteroid discovery something that can be done with their data without having to put in place their observational schedule against that science objective. So stay tuned.
Any citizen science programs coming out of this, like data analysis? I know there's a lot of citizen scientists out there that are doing data analysis now.
Yeah. So like I said, our software is for people who are astrodynamicists and pretty geeky. We've got a couple of tools that I mentioned. We launched a pre-covery service. So if you're looking for an asteroid and want to see if it's been by before, you can put in its parameters into pre-covery, and you can find out whether or not we've seen it before. So the development of these tools are critical to the whole process of servicing the science community. And so LSST has got a solar system science collaboration group. Solar system science collaboration. I think that's what, and so they're going to be our first users. You know, we've been starting to sort of open up some of the tools. You can go to the Atom website and have a look at the two that are there right now. Expect to see a few more before LSST goes, before Vera Rubin goes live. But, you know, our first users are going to be pretty sophisticated users because our tools are not going to be intuitive. The inside tools, I mean, we'll be exposing outside tools like we've done with the two services that are out there now that, you know, anybody can use if you understand how to use them or the purposes of them. But we expect citizen science is going to, you know, be something that will have a lot to provide in the next 4 to 6 years. But right now, for us, from an engineering perspective, for what we are developing, the most important thing for us right now is to be ready to receive the deluge of asteroid data that's going to come off of LSST. We want to be ready to crunch the numbers as that data is coming in, to do the kinds of, you know, I showed you the Monte Carlos, where is that asteroid now? Where might it be going with the observations that we have? And then where the, you know, community may probably come in because the community is already involved is through the Minor Planet Center, right? So, you know, they put up an alert, they say, this is something interesting. Can you give us some, you know, some better observations on it? Our data will go from LSST into our system and then be published out to the Minor Planet Center. So citizen scientists will be helping us when we find new asteroids that need follow-up observation. So that's probably the earliest way in which the public would be interacting with what we're building.
I imagine that this whole thing falls under the category of big data. What are the data requirements for this looking like? I mean, you talking petabytes or more?
I think Vera Rubin is 5 petabytes a night. It's the biggest data set a night. Yeah, it's big. It's it'll be the biggest data set of our solar system and beyond ever. And I think it's also one of the things that we talk a lot about is that astronomy was done through telescopes that, you know, individuals had, and we're moving into the age of computational. We're moving into the age of computational astronomy. So that means the tools for people who want to do astronomy, want to be, you know, planetary scientists, that's changing. And so there is this thing of there, you know, are the universities teaching students what working with big data means for planetary science or for astronomy? And the University of Washington is one of the, you know, leading places where they've got a group that's called the eSciences group. We work closely with another group that's at University of Washington called the Dirac Institute, stands for Data Intensive Astrophysics and Cosmology. Because there are people who understand that this new world is coming as computers get better, as our ability to program and to program thinking into computers. We're going to need an informed set of scientists and learners who are going to come in behind. So this question about big science, big data, is absolutely, you know, there's a gap.
Well,
there's going to be a gap from where we are today to how quickly astronomy is going to change in the coming, you know, decade.
It's funny that you mentioned that because the summer school here, the Vatican Observatory, every other year. I work for the Vatican Observatory Foundation. I work with Brother Guy, right? So every other year they put on a summer school in Rome, and next year's summer school, which I just put a link in chat for, their topic is big data and how you do data analysis on big data sets, and they got several people talking about that. So and I just thought that was interesting because this is what they're talking about.
That's great.
Yeah,
That's great.
But yeah, the big data is something that I've gotten interested recently because with all the new surveys coming online, like Gaia, oh my God, and but they're talking about, oh, I can't remember the name. There's a radio telescope that they're doing a gigantic array in, I think, Germany and Australia, and it's going to be producing like petabytes of data every day. Everything, we're in the petabyte range per day now for single telescopes. It's crazy.
It's exciting.
Yeah, it is. But I mean, I wish I knew how to do some of this stuff like you're talking about, the data analysis, but that was I am not in college right now. But I
Okay,
see
you learn how to do just about everything online from what I hear from the younger generation.
well, yeah, my son-in-law is a real big you can do it if you can't find it on YouTube, you just can't find it at all.
That's
But
right.
so anybody else have questions about Planetary? Hey, I do. When are they going to test the gravity tractor?
Yeah, so some of you may remember that there was a proposal by a prior administration called the ARM mission, and it got canceled. Embedded in the ARM mission actually was a proposal to test the gravity tractor concept. So as far as I know, there's not a gravity tractor proposal on the runway that has any funding. So we haven't tested that yet. And we should.
The other thing I saw, which is pretty interesting, I know that Planetary Society had something a couple years ago about laser bees. Essentially, it's a bunch of like a swarm of satellites that have solar panels and ultraviolet lasers, and they all focus onto a single point on the asteroid, which vaporizes it. You've got rocket engine, and you can make the asteroid go whatever way you want that way. I'd
Yeah.
like to see that tested. There's a dozen different methods I'd like to see tested, but
Yeah.
I'm going to have to change my asteroid lecture because I always talked about, and this was from, oh, I got it from who was the former guy at JPL? I think it was Dan. I can't remember. He wrote a book and he talked about kinetic impactors not being as effective against rubble piles because they're rubble piles. Well, that's been disproven. They're pretty darn effective. And do we think the debris haze is going to be gone by the time Hera gets there? Because I know there's a lot of crap around that thing right now.
I know, pretty exciting. Yeah, they didn't. I mean, this is all very new science, right? They most of the scientists that I've talked to did not expect that debris field.
Yeah, for
Right?
those of you that don't know, the DART mission after it hit Dimorphos, for days, telescopes and everybody was posting on Twitter. I got new pictures, got new pictures, but it formed essentially the asteroid formed a tail, and stuff was being blown off by the solar wind. But I went looking today. I haven't seen a new picture about it, but the Hera mission is going to be going back and looking at that, and I just hope there's no stuff
Right.
still around there, like maybe a ring.
But this is what I was saying, which is that we're really entering into the decade of asteroid discovery. So Hayabusa 2 went out and gathered a sample. The samples, we're starting to see the research papers that are coming out of the Hayabusa 2 sample. OSIRIS-REx, a NASA mission, will land in the desert in
Not very
Utah
long.
in September. In September, I can't read over on my wall. In September, we're going to learn a lot from those samples. And then when they were visiting the asteroids, they were seeing behavior that they didn't understand, like these eruptions and, as it was spinning, the things are coming out and then coming back together. And so these are objects that we're just starting to learn really amazing things about. So the debris field, I guess we'll find out what happens, what the scientists, sort of have to say about it. How long does that trail live there? One of the other things is, the asteroid's orbit was changed by 30 seconds, I think. And they had anticipated it was 10. And so, that was a big lesson, right? They sort of had their guess, their range, and then it was knocked out of the park, right? 3 times what they had anticipated. So it's new. It's new. Like we're just starting to understand them, explore them.
Absolutely thrilled about that.
One of the other space missions that we didn't talk about, you mentioned sort of the origins of when I first arrived at B612, we were trying to fundraise for a mission called Sentinel, that would be an infrared space-based telescope. And based upon the National Academy's recommendations of the best way to find asteroids, we had proposed that Sentinel would be in a Venus-like orbit. So, we're always surveying the orbit region of where Earth is spinning.
Essentially looking up at Earth.
Yeah. So NASA has a proposed mission called the NEO survey, used to be called NEOCAM, that is anticipated that it will fly in 2026. Infrared, so it's going to give us a lot more information about the asteroids. It will be at L1 or L2. And so we'll get a lot of new exciting data from NEO survey if it's funded and flies, fully funded and flies. That will also add to our database of understanding about these celestial objects.
Cool.
All right, so I've been listening to Bob dominate the whole question and answer session.
I'm an asteroid fanatic. What can I say?
I do have a question, and it's about looking for asteroids in the sun. I had heard of some efforts to do this with, I guess there's something that's going to look 10 minutes after sunset and 10 minutes before sunrise because we're able to actually see something. But are there any other missions that they're attempting to fund to intercept asteroids that are coming in from the sun, like Chelyabinsk was?
Yeah, I think that I think there's a proposed mission of, I think it's called Comet Interceptor. I'm not sure its full name. I think it's out of ESA. It's proposing to have, sort of ready out there to do a nudge or a push of an asteroid. LSST is going to find a lot of asteroids just by virtue of where it's placed. But that problem of, looking into the sun is a real issue. And that, in fact, was whatever it was, 2022 BP9, right? That was a 1.6 kilometer asteroid that, was not in our inventory. And whoa, here it comes from the sun. So there is a new telescope that's gone online. I'm drawing a blank on it right now that actually is, surveying that sort of time horizon as, the sun sets, which is a good time to be looking for objects. So, it's simply all of these things. This thing about, discovery is simply a funding issue, which is why, creating Asteroid Day was important to us. We need to encourage our governments and our institutions and, private industry to fund this technology to, increase the rate of asteroid discovery. It's not going to happen by itself. It's not going to happen by a little organization like ours. The public, all of you, if this is something that you think is important, you need to advocate for it. And this, the Planetary Society has been, really good at that, right? I love that they created I think it's a Planetary Defense grant. They do their big fundraising leading up to Asteroid Day for the Shoemaker grants that they do. It's a funding problem. It's not a technology problem. Like we have all the tools that we need to find asteroids. We have not deployed them to find asteroids. That's the main issue.
Okay. Hopefully they.
So we're
Adrian.
Whoops! You broke up just a little bit before.
Hit me with another one, Adrian.
Yeah. Yeah, I have to come up with another one. No, that's my main one because as I recall, Chelyabinsk came in from the sun, and I recall reading some other proposals some years ago about a spacecraft that could sit in between us and the sun and look for those near Earth asteroids. So
Oh, that might have been
so
Sentinel.
hopefully,
Might have been Sentinel.
yeah.
That might have been
Okay.
Sentinel. But the reality is that Chelyabinsk was a small asteroid. So it was 19 meters.
Right.
And most scientists before Chelyabinsk thought that an asteroid that size would never make it through our atmosphere. So that was new science for them. Oh, hey,
Surprise!
check it out.
Oh,
It gets through the atmosphere. Oh, it might cause some damage, right?
it
Um,
did cause damage.
yeah, exactly.
Yeah.
Exactly. So
So
we're all students learning together right now, right? And it's just a question of the will, right? And so I'm lucky enough to work with some folks that, started this organization early with a really clear mission. It's not very often that you can work on a global existential threat that clearly has a solution if we knew that they were coming. We can't say it about a hurricane, a tsunami, an earthquake, a super volcano, right? If we know where it is, pretty darn sure we could do something about it. And the only problem that we have is a funding problem. NASA's not funded, ESA's not funded, universities who, want to build more telescopes are not funded, space missions are not funded. So that's why Asteroid Day was really important, because an informed electorate, an informed public who cares about both, hey, they might wipe out my hometown, unlikely, but it might happen. And hey, they're also interesting because, they brought this water to me. I would not be here without asteroids, right? They brought the water of life, the ingredients of life. Um, and they'll be amazing places for us to visit as, we become a spacefaring civilization, which, is inevitable in the next 50 to 100 years. I mean, because humans just like to explore. And so it's really a question of funding. It's a question of funding and making sure that people are aware that this is a problem, it is a risk, but there's also opportunity. There's opportunity from science. There's an opportunity from understanding the origins of life on this planet. Some people want to think about, space resources utilization. By the way, the first thing that we'll probably want to get from an asteroid is water to use as fuel, perhaps to move out into our solar system. So forget about the platinum and, trillionaires that are going to be made from, rare earth minerals. Water is a pretty important first step from a resource utilization perspective. So I'm glad everyone's here learning about asteroids because I think they're pretty cool.
Yeah.
And I know that if we all work together, we actually could, put this existential risk to bed. And you can't say that about many things.
all right. Well, you did drig up one other question. I don't know how long, Bob, how long before we have to call it quits
We
on
can
the
keep going until 9:30. We got another 20
Okay.
or 10 minutes, 12 minutes. So what do you got?
Okay. Well, the other question that I thought of was where the priority in missions, because we just saw a rocket blast off and head to the moon,
That
which
cost a lot of
there are
money.
some meteors that have come from the moon. Yeah, it costs a lot of money. Where in your estimation, how do we balance the budget needed to search for these asteroids as well as any other spacefaring missions, including possibly manned or womaned missions to space?
So the Planetary Defense Coordination Office's budget, which is a very tiny part of the NASA budget. I think maybe it's $60 million right now, and it's largely funding Pan-STARRS and Catalina Sky Survey, and some of the Minor Planet Center and some new innovations. But that was the budget that funded the DART mission, right? So it did get prioritized.
Yeah.
It did get built and it did get launched, and we are in the process of learning about it. Now, in America, we can go lobby Congress and we can say, this is an important thing. You should give more money to the Planetary Defense Coordination Office so that they can do more work, right? We can do that. Not so much the case in Europe, not so much the case in China or Russia, but here in the United States, we can have our voices heard about what our funding priorities are. So the budget is too small. That's the first answer. The budget for this work is too small. And it is through the advocacy work that B612 did, when we first started, where the founders, Rusty in particular, said we need to fund this planetary defense mission. We need to understand this is a real issue. And that helped build awareness to create that office, to ensure that that got funded, and other people piled on. So like one voice can make a difference. I really do, yes, there were many voices that, have come together over the last 20 years, in particular, the Association of Space Explorers. So that's the club of people who've been to space. There's about 560 of them right now. And the ASE helped us actually launch Asteroid Day. But more importantly, before I arrived, about 15, 17 years ago, B612 raised money for several astronauts to go to the United Nations to start this conversation about how important it is that we actually pay attention to planetary defense, because it's going to be a geopolitical issue. So just like when I was showing you the Earth and all the possible places, as we find that asteroids potentially have our address on it, it's going to take us a while to fine tune where the orbit is, where it might hit. And so it's going to be crisscrossing across borders. So this problem, like when we find out that there's one coming, is a geopolitical problem. Because if you're Europe and it's coming over you, you're going to want to nudge it to the left, right? And then, does Russia like that idea? Maybe not. And so,
and if it's
if
it's a global killer, it doesn't matter where you nudge it.
That's right. So B612, helped raise money for the ASE to start this UN committee called Action Team 17. And it was really a group of people that started a conversation at the United Nations level that says this is going to happen. The UN and countries should be aware of it. And so now today, there's two groups at the UN that was an output of that work that took about 10 years. One's called the Space Mission Planning Group. And so that is representatives of the spacefaring nations, plus a couple of other, advanced, space company kinds of representatives. And then there's another group called the International Asteroid Warning Network, again, made up of representatives from nations around the world. Those two groups are not well funded. Seems to me they're doing pretty important work from a geopolitical perspective, right? So why aren't they funded? It's not a lot of money to, make smart people come together and really work through the checklist. What is the protocol? They've made some good progress, really good progress, actually. Communication protocols, NASA or ESA probably in the lead, because we have more telescopes. I'm invested more heavily in it. But there's another example of like, why aren't those two important groups better funded? Because it's not a priority yet. And that's why we need the public to care. That's why we created Asteroid Day. Give pressure on these groups and say, fund this work. Any one of you could be making a difference with your voice. And that's what this organization is.
I also know what we're up against. I mean, the general public, it's you mentioned if Chelyabinsk could happen in New York, how funding wouldn't have been a problem at all. And in my pessimistic estimation, I almost wonder if it takes a New York Chelyabinsk in order to have the funding come in, because then it becomes an immediate threat. You know, the day before the Giants win the Super Bowl, we're all worried about that. And if MetLife Stadium's blasted by an asteroid the next day, suddenly people with deep pockets say, you know, I don't want this to happen to my house, so here's a gazillion dollars to do whatever it takes to keep this from happening to MetLife Field ever again, or Yankee Stadium, which I'd give money at that point because I'm a Yankee fan. So at any rate, yeah,
The downside.
Asteroid Day, I do get that as a good start.
Okay, since you brought up stadiums, I have to show you. This is my business card. Okay. And on the back, can you see what's there? That is the FedEx Stadium.
I see a rock, and I see
the Atlanta. That's Atlanta's FedEx Stadium, and the
2012
little
DA-14.
It's DA-14 and Chelyabinsk. And
I am
DA-14
such a geek.
And so it shows just how big those are.
That's
and
right.
How easily it would blast that stadium.
Yeah, that's 19 meters, and that was 45.
So I would like to point something out. If you remember Comet Ison, that spectacularly what was going to be the comet of the century and flew around the sun and disintegrated. Well, it was discovered.
I remember
1 year before it made its pass by the Earth, and it came pretty close. Now, if it was on an earthbound trajectory, we found out about it 1 year beforehand. What could we do about that? That would be a scramble. We might be able to do something now. I'm not sure back in 2012 we could have done anything, but if
Well,
we
as I
if we had
recall,
a
we made a
year,
couple of movies about it. There were a couple of movies. One was built with Bruce Willis, and the other one,
I was actually going to ask that. Which,
actor.
what's your favorite asteroid flick?
Well, the scientists
Armageddon or Deep Impact?
The scientists agree that Deep Impact had much better science. So that's the answer from my friends.
And that was the comet, right? With Blair Underwood. Yeah, they all gave their lives to. If that was the right one, they all gave their lives to try to chop the comet in half. But truth is, both fragments still probably would have hit Earth. If I, as I recall,
yeah,
they ended up deciding to drill and blow it up.
I guess I'm not being good because I haven't watched it in 15 years.
Yeah,
I haven't seen it in a while. I'm trying to remember. Yeah, I think in one, they flew the nukes into the comet and blew the bigger piece up.
Doesn't that violate
so
the
that it would
peaceful use of space treaty right there? Having nukes in space.
Yeah.
Yeah, they did that. Both of them did that. Both of them had nukes. But one of the one with Bruce Willis sacrifices himself to hit the button and split the asteroid before it gets close enough to Earth, so both pieces fly off of the side of the Earth. The
ramming robots
Deep
into
Impact,
asteroids isn't sexy enough.
they blow a small fragment off and it hits Earth, but they incinerate the large fragment by sacrificing themselves and their ship by flying right into it. They were the DART mission, and so when they blew up, somehow the large piece of the comet incinerated and did not hit Earth. So only a few. So President Morgan Freeman declares that they'll rebuild again after a few tsunamis wipe out the coasts. And that was the synopsis of Deep Impact. Yeah.
Tidal wave, though.
Yeah.
Yeah.
So on that,
wiped a few people out.
On that note, I think I need to sign off so I can go.
Alrighty, it is. Yeah, it is coming up on 9:30. So
don't look up.
Exactly the theme.
Everybody give a round
if my
of
memory
applause
serves
to
me
Danica.
correctly.
Thanks so
And
much. You were great today.
thank you
Thank
very
you.
much for coming and presenting. I really appreciate it.
Yeah, and thank you, Bob, for your leadership with
Oh.
Asteroid Day and jumping on very early and being part of the asteroid, worldwide asteroid educators. It really
Oh,
made a
listen to
difference. So
her.
thank you. Thank you.
All
One
right,
of you
thank
give me the date of Asteroid Day so I can put it down.
June 30th.
I think I missed it.
The anniversary of Tunguska.
Tunguska Day, June 30th.
June 30th.
And
Got it.
you can go to asteroidday.org, and we've got tons of tools. You can download, host your own event, party ideas, curriculum, videos from all the authoritative folks.
Yeah, I
And
think I'm
then,
going
of
to have the
course,
WASP try and do something this year. I know that Cranbrook has been. They were, when John Zawicki was alive, they were doing something, but they didn't do anything last year. So I'll have to see if I can tweak them again. Get that
great.
going
And
again at Cranbrook.
I can't sign off without saying we are a charity at B612. Your dollars really matter to us. And this year we're really excited because Tito's, as in Tito's Vodka, has given us $1 million challenge. And so every gift will be
Wow.
doubled by Tito's through the end of this year. So if you ever think about wanting to support
Tito's
people who are working on planetary defense, b612.org.
All right.
Okay.
All right. Thank you very
We will
much.
keep that in mind.
And with
Thank
that,
you for
we're gonna
giving us
close
your
this meeting
time
down.
and
Yes,
expertise.
thank you.
Take care. Bye.
Night,
We'll
everyone.
see you later. Good night.
People slowly filter